Okay, so let me know which ones you'd like me to do. Go through the exam. On review 1, number 4. This is review 2. You want me to do number 4? Okay, so you try it and then I will show you the answer. And we'll solve it together. So this is the formula sheet for the exam. Almost everything you'll do, I think, pretty much everything on the final exam can reference to one of these formula. So for this problem, which one should we be using? Which one should we use? That's the best way to start. So it's a question about the mean. Given the mean of 250 hours and standard deviation of 15. What information is this? Is this sample information or population information? Very good. It's population, Patricia. So we're told that lifetime is it doesn't tell you the shape of the distribution, but it has a mean of 250 hours and a standard deviation of 15 hours, where X is a lifetime. Bomba, right? A bulb. Suppose we have, I think that's what you guys call it. I'm sorry if I'm wrong. But it's a bulb. Suppose we have 30 such bulbs. So N is 30. And each time a bulb burns out, it is immediately replaced with another bulb. The approximate probability that 30 bulbs last a total of 7,550 hours is, so the issue here is, we did not learn how to deal with totals of a variable explicitly. What we focused on was, we did proportions, we did proportions, then we did means, right? So here is what we're going to apply, because it's not totals, but it's the mean time. Okay, it's not proportions, but it's going to be the mean time. So we're going to use number 3 here. Oh, let me paste. Okay. May have to slow down. Okay, so there's the theory for us. So because of this, and size is more than 25, then the sample mean, the distribution of the sample mean is approximately normal with a mean of 250 and a standard deviation that is smaller by a factor dividing by root of n. So it's 15 over square root of 30. How much is that? Right. So we can round it. 2.739. And now what do we do? Okay, so we have information about the distribution of the sample mean. But the question regards total. So how do I convert the question to apply so I can apply this result? Bombilla, that's it. Thank you, Patricia. Bomba is a pump, I think. To me, it sounds mostly the same, but I have to be careful. 30 bulbs last more than 7,550 hours. How do I convert that? So 7,550 hours total for 30 bulbs, or an average of 251.667 per bulb. Now that's what we're going to test. Okay, go ahead and test it. I'm going to get some water. What are you guys doing? What's happening? You want to test, it says the approximate, or you want to find the approximate probability that 30 bulbs last more than a total of this is the same as asking for the probability that X bar is greater than 251.67. We'll just do 667 and then we'll fix it. So then we standardize this to find the probability using this information here. So I've converted the question. So this is from SDS of the mean. So you convert X bar into Z by taking 251.667 minus 250 divided by 2.739. And you get the z-score. What do you find? Well, it's only two. The z table is in 2 decimals, so we'll make it 6.1. So you go to the tables or use your Excel, draw a picture, and 0.61 is here maybe. So when you look up 0.61 in the margin, if you go to the table, 0.61 is here, 7291. Right. So this side, the left, the table only gives you the left. Don't forget that. So does Excel. 7291. It gives you percentiles, right? That's why that's what we do. So then to calculate this, you need to go 1 minus 7291. And that is your answer. So the answer is 27.09%. The option there? Yeah, it's A. Okay, what other one would you like to do? 16 from the mock exam. Right, 16 from the mock exam. Okay, so it's using questions 15 and 16. How am I going to put this here? Let me sort. So those are the solutions to the mock. So yeah, there's 16 multiple choice questions. And I asked you to use 15 and 16 for this problem. So refer to the question directly above. The representative selects a random sample of 16 bags to complete the test. The mean is calculated to be 73 grams. The standard deviation is known to be 5 grams. The value of the appropriate test statistic is what? Okay, so because you have been given, so this problem is hypothesis testing. And I guess the only question you have to sort out is which one of the formulas do you use? Which row do I use? 4, 5, or 6? That's the essence of the problem. Five, right? Because we are going to do this because this was for inference on mu sigma known. Yeah, mu is unknown, but sigma is known. So you can do this. That's why the answer is Z. So let's put the values together. Oh, well, I'll just recopy it. So Z is equal to X bar minus mu 0 over sigma over root n. So the test, so let's go through what we have here. So this was the sample size. The mean is calculated to be 73. Which mean is this one? Well, mean, what does that mean? Mean, what does it signify, indicate? Very good. That's the sample mean, X bar. And then the standard deviation that I gave it to you, right? Because I showed you sigma. So I didn't have to write that. If I write known, you should know that it's sigma. And then the only thing we need is mu 0. What is the test? The test was, what was the hypothesized mean? It was 75, right? We're going to test 75 against less than 75. That's the suspicion. So X bar is 73. 75 is mu 0. So wait, let me write that. So mu 0 is 75 from the other question. And then sigma is 5 divided by square root of 16. And that's how you get the answer. Okay. And what else? Anything else in the mock or the final reviews? Oh, question 3. What's 3? In part B? Well, back to the reviews. No, it's not the review 3, beginning of the mock. Well, that's not 3. Okay, so in a game of chance, your chance of winning a game is 0.2. If you play the game 5 times and outcomes are independent, then the probability that you will win at most once is. Okay, so first, let's look at our formulas and which one do we apply? Like 99% of the time, it's one of these, okay? Or variation of these, like basically, it's 100% from this formula sheet, but sometimes you can't see it directly, it's indirect. So in this case, this is about, let me go back. So you have information on the chance of winning a game. And you're thinking, they're giving me the chance of winning. And they're telling me how many times I play the game, and you can either win or lose. So you should be feeling like this is a binomial. So you should write up X. If you can answer these, and it's a binomial, right? So the success would be win. then I'm going to play 5 times with a chance of 0.2. And I could win 0 times, 1 time, 2 times, 3 times, 4 times, 5 times. But the question says, out of all those possibilities, the chance of winning at most once, which one of these is at most once? Or which combination of these?
Zero and one.
At most once, right? Okay, good. At most once is 0 and 1. At most once is 0, 1. At least once is 1 and up, Edgar. So it could be a language thing. If you have questions, you can let me know. If you have an interpretation issue. Okay, so then you have to get the probability of 0 and 1 and add them together. So probability x equals 0, probability x equals 1. You add them together. So the formula says how many ways out of 5 are there to see no successes? How many ways out of 5 is there to see 1 success? The chance of the success is 0.2 with, so this would be no successes times failure is 0.8, and there's going to be 5 of those because these have to add to 5 and these have to add to 1. And for this one, it's 1 success and then 4 failures. So we can simplify this. We know this is 1. We know this is going to be 5. And let me erase this, clean it up a bit. I mean, you can put it all in the calculator, but this is also 1. So all I have to do is multiply 0.8. I have to make 0.8 to the power of 5. And then here I just multiply 5 times 0.2 times this. So get the calculator. And let me make sure it's in the right mode. Second. On that. Yeah, it's in this AOS means it's in order of operation. So I can just take 0.8 to the power of 5 and I get 0. Oops, that's why I don't like when that happens. I have to go like this. 0.3277, so just keep 4. And then 5 times 0.2 times 0.8 to the power. See how it holds it? 4. And that's 0.4096. And then you add them up. That's what I get. Is it right? Is it correct? Yes. So yeah, 99% of the problems will come from some variation well, I did say 10% would be the old material, so I guess 90% will come from that formula sheet. So you need to understand how to use it. What next? That was the mock exam. So the mock exam has 16 multiple choice problems. And then in the short answer, I say answer only 5 out of 7 possible. So you pick 5. I give you all the answers. And then the third section, section C, you answer questions similar to the ones that I have in module 6 at the end. I think this one was verbatim, the one that I have. What else? If you want, we can also meet next week for an hour or two, and I can post the exam at 1. Let me know if you'd like to do that, or if you just want to get going on the exam next week. So I can answer more questions. Right, my day. So we can meet at 9. And whatever, we'll go till 10:30. If we need more time, we'll do that. And then I'll post the exam for 1 o'clock, and you'll have 72 hours. Okay, NOR 10. Can we do this question 1? You know, I don't want to pull up those old questions, but Marcos, you're gonna have to wait because I have to find that document. Maybe I can do inference 73 first, and then I'll do Patricia's question. So I'll do inference 73. I have a feeling. Inference 73. Okay. Oh, it's not 73. Inference 73. Independent random samples. Okay, so the independent random samples will not be on the test. Okay, but I let you do that for your reposition assignment. And I encourage you to understand other kinds of testing, right? So this is for independent random samples. It's not on the test. I'm not, do you want me to do it still? It's not on the test, but you basically have to identify the test statistic. This is in your notes. So it's one of these basically that, how to deal with independent samples. So we learned about dependent samples where you have, they're from the same population and like match pairs, remember? But we're on the test, I will not test you on independent samples. So there's not a lot of questions stuck here, but I believe, Edgar, you just have to finish one quiz. If you look at the syllabus, it's one quiz in each of these sections. So I have named them. Let me verify what I did here. Oh, I'm gonna verify because I changed it for you guys. What do I say about quizzes? It might not be required. Assignments and Connect, reunions, Synchronica. No, quizzes are just for practice for you. For my other course, I make them do the quizzes, but you don't have to. They're highly recommended. Highly recommended though. Quizzes are a little more challenging than my exams. Well, it's good to stretch the muscle of your brain. Is brain a muscle? Anyway, just exercise your brain. Okay, let's see. For NOR 10, we'll go back. All right, so let's see. Who was telling me to do something? Okay, Marcos wants NOR 10. Okay, NOR 10 says the weights in pounds of individuals in a population are assumed to be normally distributed with mean 170 and variance. What is the 20% of the weight? So Marcos, you have to be careful because they give you the variance. So you have to turn that into a standard deviation to apply our formulas, right? Or our approaches. So NOR 10. They tell you the variance is 400, so you need to convert it to a standard deviation, so it's 20. And then what is the 20% of the distribution of weights? Is that written correctly? Double check how you wrote that. Not clear what the question is asking. Is that why you're confused? Okay, let me go to see NOR 10 on the platform. Make sure you check the practice assignments I put up. NOR 10 says, what is the 20th percentile? Oh, you said 20%. 20th percentile of the distribution. 20 percentile is to the left is 20%. So what is the, first of all, what is the 20th percentile of the distribution of weight? So this is a backward problem where you find how many standard deviations away you are, and then you convert it to the weights. Weights in pound, weight of individuals. So this is And so, you look to the table for 0.2000. Inside the table, you know it's going to be on the negative side because it's below the mean. So you go for 0.200, which is down here. Like between these. So which one is it? Which one's closer to 0.200? Negative 0.84, right? Yeah, always draw it, Marcos. So percentile is always the area on the left. So what did I say? 0.84. So this is 0.84 negative. And now you've converted to say the weight would be Z standard deviations from the means. So it's negative 0.84. Standard deviations are 20 from the mean of 170. So that's your answer. That's A. Let me know if I got it right, according to the clave. Okay, so that brings me to, thank you for writing it out, Marcos. Check if I got it right. Let me know. Question 1 from part B of the final exam 2. Is there somebody else? Okay, so let's take some time. You can work on that. So let's meet again at 10:20. So you guys can take a break, you can work on it. I need you to work on it. You should work on it. Okay, I'm back. Over. A special soccer tournament is being held in which teams from South America compete against teams from Europe. The scheduled games for one particular day are shown below, together with the probabilities each team will win, as determined by odds makers, with some values missing. The tie games are not possible. The outcome of interest is the set of winners of the 3 games. List the complete sample space. Okay, so what did you do?
Sorry, Professor. I was actually referring to number 2 and I was working on number 2. I don't know if anybody did number 1, but can we actually discuss number 2? I'm sorry.
Oh, no. Hi, I'm fine. Okay.
In number 2, I get confused on how to really express the results. So I wanted to clear that out. And I know we need to compare it with the C and the C stat, I think, to determine if the p-value is going to be rejected or not, but I get confused on that part.
Okay, so for 2, you have a left side test. You have the sample mean and you have P. That's all we know. So you're not gonna put A and B together. You're just gonna answer A, I think. So you just get so for this, you don't have sigma, right? You just answer A.
Yeah, but then that was the problem that I had like so little information. I didn't know which formula per se to choose.
Well, when you don't have information, you use 6. You don't have S. Right? So maybe you have to use it. Let me see what happened to this question. It got distorted. Let me see what's happened to this question.
Yeah, I had chosen number 6 as well.
Hold on. Oh, I didn't even give you the answers to part B, did I? Oh, I didn't give you the part B answers. Did I? 2 CD, what happened here? I don't know. I think this is just a big typo here. Okay, so there's 4 parts to this question. Well, they're different questions. Okay. So, Yeah, they're all different questions. Okay, so you don't have, so, okay, so you don't have sigma. Oh, they give you a p-value. All right, so they give you a p-value. Sorry, I missed that. So you don't need to calculate anything. It's all there. So what would be your conclusion? That's all you have to do. Because they give you the p-value. So you jump through all the 5 steps to the bottom. You're on the, you're on the 4th step. Well, 5th step, because you have the p-value. Basically, you're concluding. You're doing the 5th step, the conclusion. So the conclusion is always to say, the point of this problem is to show you don't need to know anything to know that the test is significant or not. All you need is a p-value. That's the point of this problem. So I know it's a left-sided test, but that doesn't matter either. Well, I guess to make a carefully worded conclusion. So p-value was 0.3 is not less than 5%. So you fail to reject. So what do we say? How will you say that in words? So you fail to reject H naught. It means that it's 30. So it means that there is insufficient evidence to say that the mean is less than 30. Let me say something like that. So the carefully worded conclusion is, put it in black. There is insufficient evidence that the mean, the true mean, is less than 30. That's it. So the point of this problem, sorry, it took me a while to remember. I hadn't looked at this problem in years. Yeah, so you test here. The p-value tells you don't need to know anything about what you're testing. You just know that the test is not significant. You didn't find anything new to report. Whatever it is that they're talking about. Okay. So you get to, with p-value, you get to jump to the 5th step. Conclusion. Okay, what else? No questions? I'm just sitting here. No problems, no questions? Anybody else? We can just go. You guys can work and we can try again next week. Or during the week. If no one has any questions. Thank you, Marla. I saw your comment. That's right. I hope so. So if no one has any other questions, I'm just gonna go because I'll let you work and keep me posted if you want me to solve anything or answer anything. We'll see you next week as well, okay? I'll send an email for people who didn't make it. Update them. Thank you for coming. Steady, steady. Good day, good week.
Thank you. Bye.
Bye.
Bye, thanks.